Hi friends, this is ACS712 current sensor. This will output proportional to the current input to the circuit. This is the input, which is basically a direct line to the DC, a motor or a battery. Based on this value, we'll have output here, which will be read by Arduino project. This will be proportional to the ampere. So we are going to use this model, ACS712 model, to read the current value in our program, and we'll learn how to utilize that value also. So we'll be connecting this to Arduino along with a LCD screen and a motor and a battery to see the real-time value of the current. So let's look into the program, and then we'll see how the connection is done. So friend, this is a main parameter here. So for 5 ampere, it's going to have a value of 185 millivolt per ampere. This will be for 20 ampere, it's going to have 100 millivolt, and for 30 ampere, will have 66 millivolt. So this will be the input to the Arduino pin A0, and we're going to read, and the value will be calculated. So this is the connection, parallel connection for LCD screens. So this is a calculation for that, and as you can see, this is the offset value. So we have to carefully choose the offset value when you connect it. You select the offset value based on the point that when there is no input, the value should be 0. So for that you have to select based on the display in your serial monitor. So these are the display to the LCD screen, and there are other raw values and calculated values which are not very significant, and this is the current value on LCD screen. So let's see how the connection is done. This is my LCD screen, which is connected to Arduino in parallel mode. This is a current sensor. This is 20 ampere. I'm going to use here 20 ampere is connected to the pin A0. This is output from the current sensor, and this is taking power from Arduino. And as you can see here, this is the main input to the ACS712. So a motor, a DC motor is connected to this screen, and line is coming out. The other line of this DC motor is connected to the battery, and as you can see here, I'm going to connect this one to the battery, the other end, and you will see the screen. So friend, as you can see here on the LCD screen, the current value is currently it's showing as 0 ampere. What I'm going to do is I'm going to hold the motor. It's like I'm stalling the motor, and the current value will increase because DC motor will try to consume more current, and in that way is going to increase the value. So as you can see here, the value of the current is actually 1.3 ampere. So as you can see here, it's 1.3. I'm going to release the motor, and you'll see the value is decreasing. So value has gone down. It's like almost 0 ampere. So as I say, see, it's decreasing. So if it's 0.73, I'm going to stop the motor, and you can see the value is almost. I'm going to hold the motor. It's 9, almost 1.37. So as you can see here, friend, if you hold the motor, it's going to consume more current, and this will be the input to the Arduino, and the value here will increase. So if you're designing a Arduino robotic, you can read this value, and by checking an increase in current, you'll know that the robo is not moving because the DC motor has stopped due to some obstacle, and you can read that value, and you can accordingly take your logical decision. So these current sensors are very good circuits and they basically they'll help you in taking a decision, because the motor stalls and the currents value of current increases. So thanks for watching this video. Hope it helps you. Thank you very much. Bye.